kind of part of the point of this project is understand the continuum of the river all the way through the network. Understand all the things that rivers do and all the ways in which we as society benefit from those things. What this project is about is being able to study rivers in the way that they flow. My lab is an ecosystems hydrology lab, so we study the wetlands and streams and springs and aquifers and lakes. So the river system that we're focusing on here in the southeastern coastal plain is the Suwannee River. It's one of the only undammed rivers in all of North America, but it also is home to one of the highest densities of artesian karst springs in the world. So one of the most exciting parts of this project is rather than taking a measurement once a month or once a week and subjecting it to a suite of laboratory analyses, now there are a suite of sensors that are capable of doing those measurements immediately while you're in the field, that allow us to stitch it all together and kind of tell the story of what's called the river continuum, which is to say from the headwaters all the way down to the sea. Right now we're standing at the river rise. This is where, after about a 5 to 8 mile underground journey, the Santa Fe River is re-emerging. Right there's water coming out of the ground at an old sinkhole, discharging and forming the Santa Fe River, which we're about to paddle down. So it's a nice place to start because the water coming out of the ground here is really, this is the rebirth of the water after it's been underground for a while. And so we're going to be, over the next several days, be traversing the entire Santa Fe River. One of its major tributaries is the Ecohydrology River, also starting our descent all the way down to the Suwannee River and towards the Gulf of Mexico.
Now during drought conditions where the lower river is almost entirely spring-fed.
That's right, this is really like almost historic low flow. So we're pretty lucky to be able to sample it this time, and we'll hope to come back and get it when the river's flowing a little more vigorously. We started today at Rum Island, which is where we ended yesterday. And from Rum Island, we're going to go down through the middle part of the lower Santa Fe, which is real springs country. We're going to hit a whole bunch of big, somewhat regionally famous springs. Ginny Springs, which is a world-renowned diving venue. Gilchrist Blue Springs, which is a locally favorite recreation area. A bunch of other springs. And the river's going to be picking up all sorts of water from the Floridan aquifer, and we're going to start seeing it get clearer and clearer and clearer, but also picking up a lot of nitrate from the landscape where there's a lot of agriculture and septic tanks and things like that. We're going to be tracking both the arrival of that nitrate and also how the river is removing it. This is the part of the Suwannee that we call springs country. So there's thousands of little springs, hundreds of named springs along the Suwannee that are discharging water to the Suwannee along this reach, and we're gonna go past this big tributary of the Santa Fe River and understand a little bit about what happens in these big mixing zones where two rivers come together. And is the coming together of two rivers really the sum of its parts, or is there some interaction between waters of different type as they come together?
All right, so Matt, what are we looking at here?
It boggles my mind. So there's some conduit that's coming up between this crack and the rock, and it's higher than the river. So basically we have a spring right in the middle of the river, showing that the aquifer level is like a foot higher than the river. There's this huge boil right here, and it happens to be coming through this crack in the rock that you can see down 25 feet down to the bottom. This is karst in action, right? This is a very complicated hydrology that's full of all these underground rivers, these pipes that connect the landscape together in ways that are very, very hard to see until you see the very end of the flow path, which is coming out of the ground like this.
It's like top 5 coolest things I've ever seen.
I'm going swimming in there.
Yeah, I want to go in there too.
That is just wild. we're studying the chemistry of the river, so all the stuff that's in the water. What do you guys know what's in the water? What kind of things?
They said poop. They're very interested in poop and pee, being fifth graders.
There's poop in the water and other things too. And so that's what he's measuring. We're going to measure phosphorus in the water. You guys heard about nitrate? Nitrogen? We have a super cool thing, a big silver bullet that measures nitrate every 2 seconds. Today's run is going to be going by about 14 miles down to the confluence with the Santa Fe's biggest tributary, which is the Ecohydrology River.
As you can see, the water is very clear. Florida's springs have some of the clearest water in the world. Jacques Cousteau, the famous oceanographer, when he came to Florida and went diving in Florida springs, he joked that he had visibility forever. Under normal flow conditions, very different chemistry than the water on the Santa Fe and the Suwannee, which is that very dark, acidic, tannic water, versus this spring water that's very clear and alkaline, very high in nutrients because it's fed directly from the upper Floridan aquifer, which has become contaminated with runoff from agricultural fertilizers that leach down into the aquifer. And so where the Ecohydrology and the Santa Fe come together, we're expecting to see some very interesting mixing dynamics created by that different water chemistry.
Coming together of two rivers, really the sum of its parts, or is there some interaction between waters of different types as they come together? So it's going to be about a 25-mile day. We're going to go all the way down the Suwannee to about 15 miles downstream of the confluence near Manatee Springs. So this right here is the confluence between the Santa Fe River and the Suwannee River. Suwannee's working its way down to the Gulf over the next 50 or 60 miles. Pretty interesting place. The sturgeon are jumping in the background. There's obviously two different waters coming together. If you wade out into the river a little bit, you can see the clear water of the Santa Fe flowing, mostly spring water, mixing with the more tannic water of the Suwannee. It's a beautiful spot. And it's sort of halfway down the Suwannee River for our journey today. But we're going to continue the work and float all the way down to the Gulf of Mexico. And by looking at how things change along the entire flow of the Suwannee, we're hoping to learn a little more about the way that the Suwannee River is part and parcel of the landscape that it flows through and the kinds of things that that river is doing for us. And then we'll have a map of the chemistry of the Suwannee River Valley, which I think will be really exciting scientifically. And meanwhile, we're going to have gotten to see this gorgeous river, gorgeous landscape up close and personal.